Hello friends, welcome to today's session. Today we will be continuing our lecture series on the previous year GATE question solution. So we have already started with the electromagnetics question of waveguide. This question displayed on your screen is the one first question out of the two questions asked in the year 2019 for 2 marks. Both the questions here in the year 2019 were asked for 2 marks each. So now this is the one of it. Here, let us read the question first. A rectangular waveguide of width W and height h has a cutoff frequencies for TE10 and TE11 modes in the ratio 1:2. The aspect ratio W by h rounded off to 2 decimal places is. So now here what the examiner has given us is the width of the waveguide is W, height of the rectangular waveguide is h, the cutoff frequency ratio is 1:2, and he wants us to calculate the aspect ratio, that is the ratio of width over the height of the waveguide. So here let us first draw the rectangular waveguide. I will just draw a rectangular waveguide very quickly and then we will discuss. So let us consider this is your rectangular waveguide. This is your x-axis, this is your y-axis, and this is your z-axis. So z-axis is generally taken as, unless mentioned otherwise, it is taken as the direction of propagation. X-axis will be the width, that is a. Here in the question the width is given as W, so here a is equals to W we can write, and on y-axis we can say it is a height denoted generally by b, but here in the question it is given as h, so b is equals to h. So now examiner is talking about the cutoff frequencies of different modes. So for the question which should arise in our mind is what is exactly the cutoff frequency is, why it is important. So let us first discuss what is cutoff frequency. So basically you all might have known a term called as propagation constant given by gamma bar. So the equation which we will write for propagation constant is alpha plus j beta. Basically propagation constant is telling you the how the wave is propagating, means which part is getting attenuated and which part is getting propagated, how much wave is attenuating or it is attenuating or not, whether it is propagating or not. All these things you can extract from your propagation constant. So it is given by alpha plus j beta. One more formula you have for your propagation constant based on your dimension, related to your dimension and frequency of operation of your waveguide, which is given by square root of m pi over a whole square plus n pi over b whole square minus omega square mu epsilon. But here, as we already know that value of a, that is width, is given in our question as W, and value of height, which is b, which is given as h in our question. So to remain consistent, let us directly remove this a and b, and in place of this a and b I will write W and h, as we need to obtain our solution in terms of W and h. So now there are two parts to this thing, this equation of propagation constant. This is your first part and this is your second part. Now we can say, as here in this first part, this mode of propagation m and n belongs to which mode of propagation you want to travel. which generally we decide and then we will not change. W and H are the dimensions of your waveguide which you cannot change. So let us say once the wave travels, this first part always remains constant. You might change it. If you want to change the mode of propagation, then you can change it, but generally once we are fixed with the mode of propagation, we will not change it. And here in this second part, mu is your permeability, and epsilon is your permittivity, which is constant for whichever medium it is. Let us, if the waveguide is filled with some air, it has some mu naught epsilon naught values. If it is some other dielectric material, then mu r and epsilon r also comes into picture. But the thing is, for each material, your values of mu and epsilon r always remains constant. Now we have here, we can change the frequency of wave, frequency of operation of wave. As soon as we change the wave, we can change the frequency of operation. So let us say here, when the value of your omega, that is your frequency, might be, we can directly write down here for the sake of understanding, omega is equals to 2 pi f. So we can say, as these are directly proportional to each other and only related with a constant, so we can say frequency to omega as well. So when the value of omega is less or lower, we can see here we have a minus sign. When the value of this part is lower, that is, it decides the value of frequency will decide the value of this equation, as mu and epsilon are constant values for specific material. So when this value of frequency is lower, this complete equation 1 minus 2 is always real quantity. And when the value of omega is very high, that is, we are operating at a very high frequency, then 2 becomes greater than 1 and the value of your propagation constant will become imaginary. So when the value of your propagation constant is real, we will say that alpha exists, that is, attenuation constant exists, wave cannot propagate at lower frequency. And when the value of your propagation constant is imaginary, then phase constant exists, that means your wave is traveling. So at low frequency, we can conclude here, at lower frequency the wave will not be able to travel or will not be propagating, and at higher frequencies the wave will be propagating. But as we know, here we define a limiting frequency, that is called as your cutoff frequency, that is, you can say omega c or fc. As your waveguide acts like a high pass filter, so you might have known these things. This is your frequency, this is your stop band, and this is your pass band of high pass filter. So at some frequency, we are considering it as fc, or if you take this omega fc or omega c, at this frequency your value of gamma, that is propagation constant, remains 0. So as soon as your value of propagation constant remains 0, this becomes 0. We'll go to the next slide. Then we can say square root of m pi by w. First thing, don't get confused with this w and omega. This w is your width and omega is your frequency, plus n pi by h whole square minus omega square mu epsilon, or that this is your cutoff frequency omega c, which is equals to 0. So by solving this, we get for cutoff frequency omega c as 1 over square root of mu epsilon into square root of m pi by w square plus n pi by h square. So this is the value of your cutoff frequency. Now the examiner says the ratio of cutoff frequency omega c of TE10 mode. Here ratio, the cutoff frequencies for this mode is in the ratio of 1:2. So omega c of TE10 mode with omega c of TE11 mode is equals to 1 by 2. So now obviously we can conclude that W will not be dependent on your any mode, because it is a value of dimension of your waveguide, as well as H will also be not dependent. So now this M and N value is dependent. So if you want to know more detail about the dominant mode and different modes of transmission of the waveguides, you can I have discussed this in the very detail in the solution of electromagnetics waveguides problem which appeared in 2021. So you can go there. I will not be discussing it in detail, but then for, let us see omega c for TE10 mode. Here as we are writing 10 means m is equals to 1 and n is equals to 0. This is for TE10 mode. Okay, so this is equals to, here m is 1 and n is 0, so this part will be neglected. So 1 over mu epsilon square root. So this square and square root we can neglect, but right now we will just keep it for the sake of comfort of calculations. Pi by w whole square. And similarly for TE11 mode, value of m is 1 and value of n is also 1. So omega c for TE11 is equals to 1 over square root of mu epsilon square root of pi by w whole square plus pi by h whole square. So now we already know the ratio of this and this frequency is 1 by 2. So now we will be dividing this equation with this equation omega c TE10 with omega c TE11. So we'll go to the next slide and we will divide. So 1 over square root of mu epsilon will get cancelled. So we can directly say the numerator will be pi by w square over again square root of pi by w square plus pi by h square, which is equal to 1 by 2. Now this pi will get cancelled. You can take a square of this, so we can say 1 over square upon 1 over square plus 1 over x square equals to 1 by 4. By solving and simplifying this equation, we will get over h whole square is equals to 3. So we can write down here w by h is equals to square root of 3, which is equal to 1.732. And now the question says they want round off to 2 decimal places, so we can round it off to 2 decimal place. That is, here I am writing w by h is equals to 1.73. So this is your answer. You can type in when you will attempt your paper, you can directly type 1.73 as your answer. Okay, thank you for today. That's all.